Hi, Rahul's math videos. Today I am going to do property 4 of vectors, dot product of two equal vectors. Suppose you have two vectors. Let this be vector A, and let's have another vector, vector B. Okay, so now you have two different vectors. Let the angle between these two vectors be theta. But now, as I have said, these two vectors are different. We are doing the dot product of two equal vectors. Now, if we take
I have a question, Rahul.
Okay.
When you call equal vectors, always vectors need not be equal, right?
Yes, vectors need not be equal. Two equal vectors are vectors which have the same magnitude but not necessarily the same direction.
Oh,
Magnitude of the two vectors is going to be constant for two equal vectors. So now A and B can be two equal vectors, but by only virtue of their magnitude. But as you can see here, B is in this direction while A is in this direction. Both the directions are different.
Yeah. So here, when they say equal vectors, their direction is also same and their magnitude is also same.
Exactly. That is exactly the case that we are taking here. Now, if you take vector A and vector A, how will the diagram be? It is going to be something like this. Vector A and vector A are going to lie on top of each other. So, when two vectors are lying on top of each other, what is the angle between them going to be?
0.
Exactly. The angle between vector A and vector A is going to be 0 degrees. Okay? So, what is the formula for dot product?
May I give it a try?
Sure.
It is A magnitude of A vector multiplied by the magnitude of the other vector multiplied by the cos of the angle between the two vectors.
Exactly. That is the definition on the formula for dot product between two vectors. Now, as we have already seen, A is lying on top of A, which means that the angle between A and A is 0 degrees.
I have one stupid question, will you allow me?
Sure.
What is that? If I take A vector multiplied by A vector, what does that mean?
Multiply is not the correct definition or the term that we should use in this case.
In vectors, right?
In vectors. When it comes to vectors, multiply is the wrong term. When you are dealing with vectors, you should always say either dot product or cross product.
Thank you.
Okay. Now, dot product between vector A and vector A is what we are considering here. Since the angle between vector A and vector A is 0 degrees, theta can be replaced with 0. Do you agree?
Yeah.
So, what is cos of 0 degrees?
I know it should be 1, am I correct?
Exactly, cos of 0 is 1.
So what is the other thing? Cos 90 is 0, right?
Cos 90 is 0 and cos 0 is 1.
Cos 0.
Since cos 0 is equal to 1, this can be rewritten as vector A
Modulus of
vector A into 1. Okay.
So modulus of vector A means it's scalar number,
It's
right?
a scalar number.
Okay.
Magnitude of a vector is always a scalar quantity. A scalar quantity is just any number which has no units and nothing attached to it. It is simply a number. So when we write,
So you mean to say no direction, right?
it has no direction.
Okay. Right.
The number 1 is a scalar.
Okay.
If I asked you what is the direction of number 1, what would you be able to tell me?
Something like acceleration of 1 kilometer means I get a scalar.
Exactly, you have direction. The car is going in this direction with so much velocity. That has direction and a magnitude.
Okay, if not, it is called a speed, right?
It is called a speed.
It is useless, okay.
So we'll leave that for now. Back to this. So we have two scalar, that is two numbers. Suppose I wrote A into A. Couldn't this be written as A square?
Yeah. So it's a normal multiplication.
Normal multiplication, because let A be any number. Let A be equal to 3. So if we wrote 3 into 3, which is equal to 3 square,
Yeah,
which is
3
equal to
square.
9, can it be written like this?
Yeah, that's what I learnt in my kindergartens.
The same thing applies to magnitude of vector A multiplied by magnitude of vector A.
That is only with magnitude, right?
Only with magnitude.
Okay, thank you.
Because when we put the modulus, we are cancelling out any direction quantities that may be there. We are taking only the number.
The arrow is gone.
The arrow is gone.
Pure.
Okay. So now this can be written as magnitude of vector A the whole square.
Wow.
Okay. Or A into A.
Wow.
I am removing the arrow and taking only the magnitude of vector A. Okay, which is equal to A square. And this is the solution for property 4, dot product of two equal vectors.